In our unit of probability, the next section we're going to be learning about is independent events. So independent events are where you have multiple events that don't affect each other. So for example, if I was to toss two coins, getting heads or tails on one coin does not affect whether or not I get heads or tails on the other coin. If I was to choose bread, meat, and cheese to make a sandwich, choosing the bread does not affect how much meat is left, and choosing the meat does not affect how much cheese is left. Rolling two dice, if I was to roll two dice, whatever I get on the first die, say 1, 2, 3, 4, 5, or 6, it doesn't matter what I get on the first die. I still have whatever's on the second die as options, as outcomes. If you have more than two multiple events, you'll need to draw a tree diagram to list the sample space. So we'll be working with the fundamental counting principle to help us do this. The fundamental counting principle tells us that if we are working with multiple events that are independent of one another, however many outcomes we have for the first event can be multiplied by however many outcomes we have of the second event to get our total number of outcomes. In this case, we actually have 3 events. So in this example, we're tossing 3 coins, and we want to know the total number of possible outcomes. Well, there are 2 outcomes for the first coin, heads or tails. There's 2 outcomes for the second coin, heads or tails, and 2 outcomes for the third coin, heads or tails. So we multiply the number of outcomes for each, 2 times 2 times 2, and that gives us the total number of possible outcomes, which in this case is 8. So now we're going to use a tree diagram to show all our possible outcomes. Here is our tree diagram. So on the far left, we have a list of all the possible outcomes for our first event. We can get heads or tails with the first coin that we flip, and here's our outcomes, heads or tails. So now that we have flipped the first coin, we're going to flip the second coin and list all the possible outcomes for it. So our second event in this case is flipping another coin. Now this would be the same whether I flipped one coin 3 times or flipped 3 coins. The same outcomes will appear. So the second event, I flipped the second coin. Well, if on the first coin I got heads, when I flipped the second coin I could get heads or tails to go with that heads. If on the first event I got tails, when I do my second event, flipping the second coin, I could get heads or tails. So I want to draw all of my outcomes for my second event branched off of each outcome for my first event. So if you move over, we see our third event. So for my third event, I want to list all of the outcomes that are possible here, branched off of each of the outcomes in the previous event. So I could end up with heads in my first event, heads or tails in my second event. But if I get heads, heads in the first event, heads in the second event, then in my third event, I could get heads or tails. So I could have heads, 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 tails. Or I could get heads in the first, tails in the second, and then get heads or tails in the third. So I could get heads, tails, heads, or heads, tails, tails. So what if I had tails in my first event? Well, in my second event, if I got heads, then I could get heads or tails in my third event. So I could have tails, heads, heads, or tails, heads, tails. And then in my last event here, I could have tails, tails, heads for an outcome, or tails, tails, tails for another outcome. So to summarize, you write all the outcomes for the first event, branch all the outcomes for the second event off each of the outcomes for the first event, and then you keep repeating this process. You always branch all the outcomes for whatever event you're on off of all the outcomes from the previous event. And then this comes together to give you all of your outcomes to list. So here I've listed all of the outcomes that I said verbally a few minutes ago, and you can see indeed we have 1, 2, 3, 4, 5, 6, 7, 8 total outcomes, which is what we expected because the 2 outcomes for the first event times the 2 for the second times the 2 for the third gives us 8 total outcomes. But now we can list them to see what they are. So we can multiply using the fundamental counting principle to see the total number of outcomes, but if we want to list them, we're going to use our tree diagram. So now we have some questions to answer. So our first question says, find the probability of having at most 2 heads. So that means we're going to have at most 2 heads would be 0 heads, 1 head, or 2 heads. So count through and see if you can find that. I have circled the answer to this question. There are 7 out of 8 outcomes that have at most 2 heads, either 0 heads as in tails, 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 or 1 or 2 heads. So the only one it wouldn't include is heads, heads, heads. Next, find at least 1 tail. What's the probability of getting at least 1 tail? At least 1 tail would be 1 tail, 2 tails, or 3 tails. So let's see if you got what I got. I got 7/8. So again, it's actually the same 7/8. Everything except for heads, heads, heads. Next, find the probability of getting exactly 1 head. So give that a shot. I ended up with 3/8, the 3/8, the 3 that are circled in pink. Lastly, find the probability that all the letters in your outcome are the same. Give that a shot. I ended up with 2/8, and of course we want to simplify that, so that would be 1/4. Let's look at this example. You're asked to find all the possible combinations of sandwiches and find the probabilities at the bottom of the page. I want to point something out with the word combinations here. Combinations is the way we're used to thinking about combinations. You put things together, but there's also a term called combinations in our probability unit that we'll get to later, and that's not what I'm talking about here. So anyway, let's move on, and I want you to start out by thinking about how many outcomes you would have using the fundamental counting principle. So let's start with the fundamental counting principle. Do you remember what I told you that it says? It tells you that you can figure out the number of total outcomes when combining multiple events that are independent of one another by doing what? Right, you multiply the number of outcomes of each. So how many outcomes do we have possible for bread? We have 2 outcomes. How about for cheese? How many options? 2, so that's 2 outcomes. And how about meat? 3. Okay, so the fundamental counting principle would tell you you can multiply 2 times 2 times 3 to get the total number of outcomes. So what's the total number of outcomes? 12 total outcomes. So now we're going to create a tree diagram showing all the possible outcomes. So I want you to think through the process we did before. We're going to start with listing. I'll start you out and let you finish. We'll start by listing the outcomes of bread, and then off of the outcomes of bread we'll have the outcomes for cheese, and off of the outcomes for cheese we'll have all the outcomes for meat. So we're going to start out with bread, so we can have wheat or plain. And if it helps you, you can label each column, but you don't have to. They usually don't, but this kind of helps kids to get started. So see if you can complete the tree diagram from there, including listing all your outcomes. Here is what my tree diagram looks like. I have my outcomes for bread in green in my first column. For cheese, I have my outcomes in the reddish column in the second column, and each outcome for cheese is branched off of each outcome for bread. And then meat, I have each outcome branched off of each outcome for cheese. Now notice I even had a difficult time making this look neat in the small amount of space, and I could not get all my outcomes listed neatly beside each place where they really go, so I just had to take as much room as I had to take. Don't worry about it being perfectly neat. And I know this is a little tedious, but it's important that you understand the process. So let's make sure we have 12 outcomes like we predicted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So now we're going to find some probabilities here. So first of all, let's see if we can make sense of what we're being asked. It says probability of PCR. What do you think that means? Let's look back at what it says up here. So P is plain bread, C is cheddar cheese, and R is roast beef. So plain bread with cheddar cheese and roast beef. What's the probability of getting that? Well, let's look at our tree. It's right here. Are there any other combinations that would be plain bread with cheese? You can see plain bread with cheese are these right in here. And there's no other ones that could have an R. So what's our probability? 1 out of 12, right? The next one says, what's the probability of white bread with S? Let's go back up here. Remember S. S is Swiss cheese. So this time we're looking for just, wheat bread. Wheat bread and Swiss cheese. So wheat bread and Swiss cheese. Let's look over here. Well, here's all the wheats are right here. And we're looking for Swiss cheese. So that's right in here. So all three of these are wheat bread with Swiss cheese. So when they don't tell you that type of meat, you have to get everything that has wheat bread and Swiss cheese. So that's going to be 3 out of how many? 12. And let's simplify that. What does that equal? 1/4. Good. All right, and then let's look at the next one, T. So what was T? Let's see if we can come back up here. T was turkey. So what's the probability of getting something with turkey? Well, here's one with turkey, here's one with turkey, here's one with turkey, and here's one with turkey. So how many is that? 4 out of how many? 12. And what does that equal? 1/3. All right, so based on the fundamental counting principle, I'm going to show you a faster way to do this. In this faster way, you won't have to create a tree diagram at all. We're going to go back to the idea of the fundamental counting principle. The fundamental counting principle tells us that we can multiply the number of each individual event, the number of outcomes for each individual event, to get the total number of outcomes. You can do the same thing for probabilities. So let's look at this first example. So let's find the individual probability for each of these. So the probability of getting plain bread times the probability of getting cheddar cheese times the probability of getting roast beef. So if we look up here, what's the probability of getting plain bread? It's 1 out of 2, right? So I'm going to put 1/2 here. What's the probability of cheddar cheese? 1 out of 2. So we're looking at each individual event here. So the probability of getting cheddar cheese when you're choosing a cheese is 1 out of 2. And what's the probability of roast beef? Well, we have roast beef, ham, and turkey, so it's 1 out of 3. And now you multiply those. What do you get? 2 times 2 is 4 times 3 is 12. 1/12. Well, what do you know? That's what we got by using the tree diagram. So you actually don't have to have a tree diagram to figure out these probabilities. You do if you want to see all the possible outcomes. So you do need to know how to do this. But I'm showing you shortcuts for figuring out probabilities. Let's look at the next one. So the probability of wheat times the probability of Swiss cheese will give us the same answer here of probability of wheat with Swiss. So the probability of wheat, what would that be if you're just looking at bread? 1/2, right? And the probability of Swiss cheese, if you're just choosing a cheese, 1 out of 2 or 1/2. And what's 1/2 times 1/2? 1/4. And then if we're looking at the last example, probability of turkey, if we look at the meat, you just look at that one event. It's a 1/3 probability that you'll get turkey out of those 3 options or those 3 outcomes. So that's a much simpler way to calculate probability.